Muy buenas tardes y bienvenidos a la conferencia del impacto de la inteligencia artificial en Colombia y Latinoamérica. Un evento organizado por el Grupo de Investigación y Desarrollo en Inteligencia Artificial, GIDIA, en la Facultad de Minas, en asocio con Learning AI Colombia y The-Learning.ai, en el marco de la celebración de las efemérides de los programas curriculares de pregrados, 20 años y posgrados, 30 años del área curricular de Ingeniería de Sistemas e Informática, enmarcado en una estrategia de eventos de carácter académico, los cuales servirán a su vez para la divulgación de las capacidades internas existentes en la universidad y que han servido a la formación de nuestros egresados y a los actuales estudiantes de dichos programas. Nos encontramos en el aula máxima de la Facultad de Minas, cuyos frescos fueron ejecutados en una cúpula parabólica de 200 metros cuadrados, diseñados por el artista arquitecto Pedro Nel Gómez. Homenaje al hombre, como fue llamado por el maestro, es considerada la obra central de su carrera artística. Le demandó al artista 4 arduos años de labor entre 1949 y 1953, logrando plasmar en 8 núcleos ligados entre sí el forma polar, el milenario espíritu humano. Nos acompaña en el día de hoy la vicedecana académica, la profesora Eliana Arango, el director del Departamento de Ciencias de la Computación y de la Decisión, profesor Jaime Alberto Guzmán Luna, así como miembros del equipo directivo de la Facultad de Minas. Igualmente, le damos la bienvenida a nuestros conferencistas, Kian Katanfurush, miembro fundador de The-Learning AI, y Alejandro Betancourt, director de Learning AI Colombia y Senior Machine Learning Engineer. Para iniciar, los invitamos a que disfruten del video institucional de su casa, nuestra Facultad de Minas. Bueno, y para continuar invitamos a la profesora Eliana Arango, vicedecana académica de la Universidad Nacional, Facultad de Minas.
Buenas tardes a todos los presentes y bienvenidos a la Facultad de Minas de la Universidad Nacional de Colombia, sede Medellín. Yo creo que todos los presentes, los que son estudiantes de aquí y los egresados, mirando este video quedamos inspirados y nos sentimos muy orgullosos de nuestra facultad. En el día de hoy, las efemérides que nos convocan son un gran evento que se comenzará a celebrar a partir de ahora. Este es el evento de inicio y seguirán varios eventos académicos para continuar con esta celebración. Un saludo a quienes nos acompañan, el director del Departamento de Ciencias de la Computación y la Decisión, el profesor Jaime Guzmán, y los dos conferencistas, para los dos conferencistas que nos acompañan el día de hoy, un agradecimiento especial. Como ya lo mencionaron, al Kian Catafurus, miembro fundador de Deep Learning Artificial Intelligence, y Alejandro Betancourt, director de Landing Artificial Intelligence Colombia. Es un honor estar hoy en una conferencia que toca un tema tan importante como lo es la inteligencia artificial en Colombia y en Latinoamérica. Un evento que es organizado por el Grupo de Investigación y Desarrollo en Inteligencia Artificial de la Facultad de Minas. La Facultad de Minas es una de las más prestigiosas instituciones de formación de ingeniería del país. Desde su creación y hasta hoy ha tenido una fuerte participación en la actividad social, cultural, económica y específicamente en el área de la ingeniería, en el desarrollo de la ingeniería en el país. En la actualidad, de cara a los grandes avances de la ciencia y la tecnología, la institución ha tenido una importante transformación que la ha consolidado como una entidad de investigación con la capacidad de afrontar y aportar al fortalecimiento de la plataforma competitiva del país. Actualmente cuenta con un número destacado de profesores e investigadores altamente cualificados. Y dentro de estos retos que tiene la facultad, tenemos en la pantalla, ya se estaba mostrando ahora al inicio de la conferencia, la especialización en inteligencia artificial, que es una de las especializaciones que está pronta a lanzarse. Las efemérides que nos convocan en el día de hoy, los 20 años del pregrado y los 30 años del posgrado del área curricular de sistemas e informática, son un gran motivo de celebración para la facultad. Esta conferencia, que da inicio a la serie de eventos de carácter académico con los cuales se celebrarán las efemérides y se divulgarán las capacidades internas existentes en la universidad, que han servido a la formación de nuestros egresados y actuales estudiantes de dichos programas, es un evento muy importante y agradecemos su presencia. Para terminar, quiero felicitar a los organizadores de la conferencia y les extiendo a todos una invitación para que continúen participando en los demás eventos con los que se celebrarán las efemérides de los programas del área curricular de sistemas e informática. Muchas gracias.
A continuación, invitamos al profesor Jaime Alberto Guzmán Luna, director del Departamento de Ciencias de la Computación y Decisión, para que comparta con nosotros una breve intervención.
Buenas noches. Hoy es un motivo de orgullo de mi parte hacer partícipe precisamente de este evento inicial de la celebración de los 20 años del pregrado en Ingeniería de Sistemas y el posgrado con la maestría y las demás áreas curriculares que se han desarrollado. De mi parte me siento muy orgulloso en esta celebración porque he sido egresado de los programas de la maestría y del doctorado en esta área curricular. yo los invito realmente a que analicemos esta gran evolución que hemos tenido nosotros con el apoyo de la Facultad de Minas, donde en un comienzo se desarrolló desde la maestría como posgrado, la cual ya se cumple en los 30 años, siendo una evolución y nos ayuda a apoyar después al pregrado con los 20 años que hoy estamos cumpliendo, y hemos tenido la labor fuerte de diversificarnos para un total de 4 especializaciones y 3 maestrías para culminar con el top máximo, que es el concepto del doctorado. Los invito entonces a seguir participando en todas estas celebraciones de este año, que sean un elemento activo como estudiantes, egresados y demás invitados, para que juntos podamos seguir esta gran celebración de este gran acontecimiento. Bueno, los invito entonces a ser participantes de la conferencia. También aprovecho para agradecer a los conferencistas para este inicio de esta celebración y agradecer también este acto que ha sido a lo del comité organizador, que ha sido un gran esfuerzo durante todo este modelo pues, de celebración que vamos a hacer. Bueno, muchas gracias.
Bueno, y ahora sí terminamos toda nuestra parte protocolaria. Este realmente es un horario complejo, pero los invito a que estemos relajados y que demos inicio a la mejor parte, toda la construcción académica. Para eso invitamos al doctor Alejandro Betancourt para que iniciemos entonces nuestra conferencia.
Okay, you can.
Hola. ¿Cómo están? It's okay if I speak in English just as an act of kindness, because Kian will have the half of the presentation in English. So let's take the main body of the presentation in English, and then the questions and answers we can switch between Spanish and English. Okay, so I will start the presentation just warming up a little bit. Somebody knows before this presentation what is AI found? If somebody knows it, just raise the hand. Okay. Somebody knows what's Arista? It's a company, but what is Arista, and have heard before of Arista in Medellin? Okay. Something more easy. Somebody knows what's landing AI? But I don't see the hands of nobody. So they know what it is because they work with me. So at least you have to raise your hand. Okay, somebody knows what's landing AI? No? Okay, deep learning AI? Okay, I can see some hands. And I have a picture. Somebody knows the guy in the bottom left part of that presentation. By the name is Andrew Ng, okay, and basically he is the founder of all the companies I was mentioning. So he is the founder of AI Found and Arista, which is a fund of artificial intelligence companies. He is also the founder of Coursera. He is the founder of Deep Learning AI, which is a company that basically creates content to train new people in artificial intelligence and create a revolution around artificial intelligence. And he is the CEO and founder of Landing AI, which is a company which uses artificial intelligence to transform industrial sectors. So today, well, basically I'm the head of Landing AI Colombia, and Kian Katan is with us also joining us today, and he's co-founder of Deep Learning AI. So we will be talking a bit. It's okay. We will be talking, discussing. Okay, this works. Now it works. Now it works. Okay, so the conference of today is, the title is Impacting Colombia and Latinoamérica with Artificial Intelligence. And I'm really proud to be in this building because it's kind of an icon of engineering for the city. And I think we are in the doors of a new transformation in the city, in the region around artificial intelligence. For me, it was kind of surprising, but now I'm super happy to know that people like Andrew Ng believes on us and want to be part of this transformation of city that we are already having for several years, okay? So today I will be speaking three things. I will discuss some of the AI trends and what's the market that we have for artificial intelligence in the world. Then after that, I will be discussing some of the opportunities that this poses to us as researchers, as engineers, as a city, to capture those opportunities. And at the end, I will invite Kian to discuss about the scaling AI talent pool. Because definitely, if we want, they are inviting us to a party, and if we want to dance in that party, we need to have the knowledge of how to dance, okay? So Kian will at the end join us and explain us some concepts of deep learning and how we can train ourselves to be part of this transformation. Okay, so I will start with some general concepts. Commonly, we have two types of artificial intelligence. Well, we can define two paths of artificial intelligence. One that is really scaring, and people usually use it in science fiction, and is general AI, and is that kind of artificial intelligence that is conscious, that can make things better than humans, that can be dangerous. But I think we have almost no progress in that side. The main progress we are having around artificial intelligence is more in the narrow AI. And what is that? Because we are creating algorithms and methods that are able to detect and solve specific problems. But those methods for specific problems can create already huge value in our companies. So we can see how companies like Google, Facebook, Amazon are creating a lot of value from this kind of technology. Let's say Google now is defining themselves as an AI-centered company. And that's basically because they are trying to put AI in every single service they provide, right? And we as Landing AI, we think that's possible, and we are helping other companies of sci technology to become great AI companies. I will give you some examples of what can be done in the narrow area. So, for example, we can go to automatic visual inspection. What's happening is that there are a lot of manufacturers with big production lines, and those manufacturers have a lot of people checking all the time if a piece is okay or is not good, okay? And that's a lot of people that basically has to stand in front of a production line checking this is okay, this is not okay, this is okay, this is not okay, and we can automatize that, okay? If we can automatize that, we can use those inspectors for educate them and make better things with them, like teach them how to do better stuff and more interesting jobs. Because at the end, when you ask those that people, if they feel happy in that kind of job, what do you expect? It's like, I'm looking for a production line 8 hours per day, and at the end I'm so tired, so I prefer to do something on which I can learn more, and then I can create more value. The other one is, you probably already have read a lot of news about autonomous driving. If you go to San Francisco, you will see that it's crazy to check cars already with the LiDAR on top, with the LiDAR on front, autonomous taxis already prototyping, and I think that's really interesting. Other part that is interesting is about recommender systems. So imagine what's happening with Amazon. When you go to Amazon, basically, I don't know if you found that it kind of suggests you the thing you want to buy before you even look for it in the search engine. That's basically because it's trying to understand how you move inside the web page and then give you some recommendations about that. And basically it's analyzing the patterns of your movement in the website, your previous purchases, but the previous purchases of other people around the world, and then mix that and can give you good recommendations of what the product that you have more chance to buy. And that's somehow really good, and that can create a lot of value. Well, I really like when I basically have some products, interesting products that I want to buy, and I just can have it directly in one click. The other thing that is really interesting, some people, actually, John, for example, I met John when I was, I don't know where is John now, but I met John when I was working for Ecopetrol, and this thing as predictive maintenance can create a lot of value in oil and gas. Imagine if you have a pump of petroleum that if it fails, you stop producing for 2 days oil, right? What if you can check the sensors and define with some time before the pump fails, send someone to fix the part that is failing, and then the pump will be continuously producing. That will reduce a lot, something that is called the deferred production, and that will create a lot of value without investing too much money. So that's something really nice that artificial intelligence can do. Other thing is assistive diagnosis. So right now there are algorithms that can predict better, if you have cancer or not in some part of the body. So that's why, because while a doctor can see a limited number of images during his lifespan, a computer can see thousands and millions of data and is able to predict that you have a particular disease. Finally, something about auto-tuning, the same example. In oil and gas, if you have the pump and you can change the frequency of the pump, then you can extract more oil without consuming too much energy and understanding what's happening in the subsurface. So that's something that we can really create with the artificial intelligence. Okay, so the thing is, following McKinsey studies, artificial intelligence is able to unlock today around $15.4 trillion globally just using artificial intelligence. And interesting there, not everything is deep learning, right? If we check there, 9.6 of those $9.6 trillion can be unlocked with traditional methods, okay? So that's good. We don't need to move everyone to deep learning immediately, right? But 5.8 can be unlocked using deep learning and neural-based algorithms. So what kind of algorithms? Well, shallow networks, convolutional neural networks, recurrent neural networks, reinforcement learning, transfer learning. Some of those probably you heard about that before. Okay, and where is that impact? Where that impact can be created? We can see that, for example, in marketing, I already give you an example, but you can see you have some impact from the traditional methods, but you can create also huge impact with neural-based algorithms, right? In supply chain, for example, what happens if you can forecast your demand much better than before? Then you can arrange all your company much better and gain and take some value from that. In the banks, in the service operations, in strategy, in finances. Well, in finances, if you can predict better the price, the exchange rate, or the price of your company, then you can take decisions much better. And that's what artificial intelligence can start doing for us. Let me go again to some examples. What if we go, well, I already speak about maintenance, predictive maintenance, and yield optimizations, right? But what if we go, let's say, something a bit more task automation? If you have a robot that can pick something and put it in another place, then you can do that automatically and more efficient. You can create a lot of value for a company like that. Well, Amazon, in this case, for example, has some sliding robots that they can take a package and put it where it has to be, and then they can arrange everything automatically. And that basically unlock a lot of value. I already speak about predictive maintenance. I already spoke about recommender systems. Yield optimization is what I mentioned about oil and gas companies, but you can use it for any other type of industry. Let's say if you have a sugarcane plantation, then you can use artificial intelligence to plan better, schedule better when you have to cut your sugarcane. You can also automatize something to cut the sugarcane and put it in production, right? So I think every kind of industry can be impacted by artificial intelligence. Okay, and this is interesting, and now I will be comparing the traditional methods that we have been working in statistics, in traditional machine learning, in normal analytics with deep learning. So what we find is, well, what McKinsey find, but I'm explaining, is that every sector, this is the percentage of improvement that you can get if you use deep learning against other type of methods, right? What is happening, I know there are a lot of researchers here because we are in the university, but if you go and check to the papers in artificial intelligence, you will find that now it's like 90% of the papers, Kian will show some numbers, is about deep learning. Why is that? Because each time we try deep learning, it kind of beat completely the other methods, right? So at the beginning, when you are a researcher and you are working in a research line with classical methods, you are like, I don't want to switch to deep learning just because it's hype. But no, now it's not because it's hype. It's because it's really beating the state of the art in every single thing we tried, right? And that has an explanation, and it's the amount of data we can have. So following Goodfellow book, basically an acceptable performance of a method, take this with a pinch of salt, because it depends also of the application. But in general, they see that an acceptable performance can be reached when you have around 5K observations per class, okay? So if you are training a classifier, you should have at least 5K in each of the classes, and then you will find an acceptable performance. That's the current state of the art, and try to, well, it's based in 2016 paper of Goodfellow, basically checking the previous papers in deep learning. And they said, okay, if we have the human performance, when we reach that performance, and if you have around 10 million observations, you can have human performance. And that's basically what in other areas they call the big data, is we are able to reach those performances because we have tons of data in our organizations. And if we take those tons of data, put it together, clean it a bit, and then start using algorithms over there, we can create human performance, or at least acceptable performance. That's 2 years ago. But I want to rephrase a bit the words of Andrew Ng in the previous talks, in the previous keynotes. And when they asked him what are the trends in the following year and in the next 2 years about AI, he mentioned the first one is the power of small data. We are training algorithms that basically with just a couple of observations, you will be able to get good performance and create value. Let's say if you have a problem for anomaly detection. Basically, what you are trying is to use a small number of data in order to create an algorithm and put it in production. Let's say if you want to optimize an oil and gas field, then maybe you can get good algorithm with 1 day observations. So those companies that were not worried about collecting data and put it in a data warehouse or didn't have the technical skills to do that will be able to already create value from that. The second one is lifelong learning. Is one of the things we observe is if you train a model and you put it in production and you forget about the model, it degenerates in time. So basically that is dangerous because that adds technical depth to your production line or to your deployment. But what if we create the full end-to-end in such a way that we can update all the time that model, so the model is observing new data coming to the database and then updating the weights, and then we have a new model deployed. That will be a way to set lifelong learning, and basically it's a model that can refresh what is learning all the time. The third trend that we can see is the AI impact outside the IT sector. Basically, if you go and check, the main more value that we are creating is in the technology sector. But I already mentioned several applications that are not technology, right? So the next trend is that we will start seeing basically artificial intelligence companies and applications all around in all different sectors. Okay, and why is that happening? And that's basically starting to explain what the opportunity we have. If you want to become a miner, at least you need to invest a lot of money in machines in order to create, to exploit a mining area. You need some soil, invest on that soil, and try to go and extract minerals from there. But in AI, is basically you need to know how to do it, you need a computer to do it, and just to a little bit more difficult is you need access to specialized computing, which basically is like you have a method, but those methods usually are, unfortunately, computationally expensive. We need a lot of computing power for that. But the good thing is we have all these open clouds like Amazon Web Services, Google Cloud. We have Azure, and basically you can pay for whatever you consume. So if you have a good client, you have a good algorithm that you already try locally, then you can scale in those kind of clusters and put that model in production. So that reduces a lot the barriers to entry in this kind of business. And finally, access to local computing. And that's why I think in Medellin, we need to, if we want to be part of this revolution, we need to invest in the people outside and the people that doesn't have a computer to train the models. So we really need to allow the people that works and lives in the bad area, let's say, they don't have access to the computer, so they can have, at least in the UVAs or in the libraries, they can have access to a computer, and from that computer, for example, you can connect to Google Colab, and there you have GPUs for 3 hours that you can use to train a model, create a startup, and basically try to create value, okay? So I really think we can start playing an important role in this kind of revolution. Okay, and how we can play on that? So the first, we need to enhance the innovation ecosystem around AI. So we really need to move out, well, we need to keep in the newspapers as we are doing, like the Artificial Intelligence Center of Latin America, the Innovation Center of Latin America, the Pact for the Innovation that we signed between all the industry leaders of the company. But we need to make it real. We need to go and teach people and bring them to AI and help them to create the startups and create value with AI. So it's time for the universities to start really going to that and helping people to create value. Then we need to consolidate and promote the previous one, and then I will. One less. Okay, promote those people. So basically try to invest on them and bring funds to them and unlock the economic growth from AI in our cities. Then the next one, I want to extend the prediction, the trends of AI, and is basically, I think the fourth trend that we are going to see is that we will see a huge economic impact in Latin America already. So let's say if we can put people with AI skills, basically that will start enhancing the economic growth. And then we can have people that before was having jobs, let's say in the store of the corner in the neighborhood, then they can start creating a startup for those stores. And then we can detonate economic growth in Latin America with that. Okay, and now to conclude, I want to invite Kian Katan. He asked me before this, like before coming to Colombia, he asked me, okay, I'm starting a course in another university here, and we have 20 students. And he asked me, okay, Alejandro, how we can scale those 20 students and have more students? So I asked him, okay, can you define what's more students? And he said, okay, in Stanford, I have per course 1,000 students. And I say, no, that's not doable here. But if we want to scale, we need to scale in the public university. So we need to put all the universities, the Antioquia University, Medellin University, National University, and even the private universities, and put everybody together in order to get that scale and put the city in the ecosystem. So I want to invite Kian for his presentation.
Thank you, Alejandro. Muchas gracias. Hola a todos. Buenos noches. Nice to meet you, everyone. So after this talk of Alejandro, I thought I would first ask, what's the crowd here? Who is a student right now here? Okay, and who's a working professional? Okay, all the rest. And professors, of course. So today I'll try to split the, how does that work? Okay, perfect. I think I got how, okay, perfect. Okay, got it. I think I know how it works. So I was thinking of starting by spending 15 minutes talking about some opportunities specific to Latin America, and based on some of the things I've seen working in other countries as well. And then we'll jump into the technical details. So the fun part is going to be the technical recap and the case studies. So if you hang on, we'll get to the fun part right after. Okay? And please stop me. I know my accent is not very good, so if you want to stop me in the middle to ask me a question, just do it. Okay? Let's go. So I think that right now, if you look at the trends around AI, so this graph shows 3 curves. The blue curve is the growth of annual published paper in artificial intelligence. Okay? The purple one is the one in computer science. And the third one is general papers. So what's interesting to note here is that there is an important growth in annual published paper in AI that has been faster than computer science. So what does that mean? How come AI, which is historically known as something related to computer science, is outpacing computer science? The reason is probably that many of the papers published today in artificial intelligence don't come from computer scientists. They come from chemical engineers. They come from aerospace engineers. They come from material science. I just spoke to one of the PhD students of Professor John, who's working in mechanical and artificial intelligence. So that's probably why we have AI papers going much faster than computer science right now. Does that make sense? So I think what we can conclude is that AI is not a domain. It's not like computer science or mechanical engineer. It's probably a layer that comes on top of many domains. Okay? So apart from that, and let me explain why I think this is related to AI. So there are many things a country can focus on to improve its artificial intelligence capabilities. But you have to deal with your strengths and weaknesses. So I think what we've seen, and I'm myself Iranian and I've grown up in France, and every country is doing it differently. So how, in Latin America, what are the opportunities with artificial intelligence? So I would split it into 3 parts. The first part is focusing on key areas. Key areas is depending on a certain economy. The second one is regulation strategically. And the third one is educating massively. So let's see why these 3 are important. Focusing on key areas. So one key area that has been working very well up to now is healthcare. So if we look at what happened in healthcare in the past 3 years. So this is a chest X-ray. So you go to the doctor, and oftentimes, maybe they will ask you to take a picture of your chest. Normally, a radiologist would take the picture, put it in front of a light, and look, can I see if there is a diagnosis to give, a problem? Many countries, including African countries, don't have as much doctors, radiologists, as you can find in big cities in the world. So these type of models helps pre-diagnose some diseases on chest X-rays. So here, this is a project led by Raj Purkar Irvine and their team in 2017 at Stanford University. And what they built is a model that you can go online and test, upload your X-ray, and it will tell you a diagnosis. It's not meant to replace doctors It's meant to assist places with shortages of doctors. Okay? So you can have a pre-diagnosis thanks to that. Other examples of projects like that are cardiologists' electrocardiograms. Is it too loud in the back or no? It's good? So, you know, some people need to have pacemakers to monitor their health. Pacemaker looks at your heartbeat and many other parameters. If you have a pacemaker for a week, let's say, it's millions of measurements, probably. Depending on the device you have, thousands to millions of measurements. A doctor cannot look at hundreds of thousands of measurements in a few hours. It's not possible. So you need somehow to help a doctor understand which parts of the electrocardiogram is important. The doctor can go there and diagnose that there is probably a pathology. Does this example make sense? Another one is improving palliative care or dermatologist level classification of skin cancer. So another project led by Andres Esteva at Stanford, they built an application where you can take a picture of your skin and diagnose eventually skin cancer. So that's again a pre-diagnosis. So healthcare has been very important to help with the shortage of doctors in some areas of the world. Agriculture is another one. Many startups in the world are growing on autonomous machines to provide more output from the same land. So, you know, countries that have big part of the economy relying on agriculture, this is a big stake project for them because you can get more from the same land. Does that make sense? So that's a very high stake project as well in many developing economies. And it's not impossible. So this one on the right, it's a little small, but it's a project that some of my students at Stanford have built in 10 weeks. In 10 weeks, they built a classifier which, given a picture of a leaf, can tell you which variety of leaf it is. So it's running on an application and people can take pictures and give you the leaf. So this is not at the same range as the farming project, but that's just to show you what is possible to do in 10 weeks. It's a class project. So companies should be better to do a lot better than that. And manufacturing, which is one of the key areas of the focus for landing.ai, and one team led by Alejandro in Colombia. So this is for focusing on key areas, examples of 3 areas. Another one is to regulate strategically. So who has heard of cryptocurrencies here? Bitcoin, blockchain, all that. So there are many startups, actually, if you look in the startup ecosystem, that failed in cryptocurrencies. And the main reason they tell when you ask them what happened, what was the main challenges you have, the answer is regulation. Many of them failed because the regulation didn't go as fast as the industry did. In many countries, it's already the case. Think about autonomous driving. How do you allow a company to put their autonomous cars in the streets? Anybody has an answer? I don't have the answer, but I think some ideas can be taken from humans. You know, when you want to have your driving license, what do? You go drive with someone next to you, and the person looks at you driving, and they look at you driving in maybe for 30 minutes. And the human assumption is, if this person can drive for 30 minutes very well, they can probably drive everywhere, right? So it's a generalization assumption. You don't need to make the person drive everywhere in order to allow them to drive. Now, do we have the same generalization assumption on autonomous driving? Think about that. If you see an autonomous car driving for 30 minutes, do you believe that it's going to drive anywhere, anytime, and under any conditions? Probably not. So this generalization assumption on humans is not always valid for cars, autonomous cars. So this is one regulation challenge. How do we give a driving license to an autonomous car? Example. I don't have the answer. So these are 2 examples of regulation problems. Another one is that 61% of digital health companies, which starts with a B2C model, it means selling to customers, end up changing to B2B. What's the reason? Oftentimes it's regulation. because insurers, health providers, and lobbies will not let this company sell to customers. That's one type of regulation. So instead, these companies pivot to work with insurers, hospitals, health providers. Because you have to understand how they work. You have to enter their network in order to be able to ship artificial intelligence models. Favorize public-private collaboration. All the projects that I've presented, or most of them in the previous page, are the fruit of collaboration between AI experts and subject domain experts. So the one with the chest X-ray wouldn't have been possible without the radiologists. It's impossible. A computer scientist cannot build that without an expert sitting next to them and telling them what's wrong with the radiology system. Okay? So that's why a good AI team is oftentimes a mix of computer scientists and AI experts, as well as healthcare subject matter experts. Does this make sense? Any questions so far? Okay, let's go. We're almost to the fun part. This is still the boring part. So educate masses, and this is something deeplearning.ai is really invested in. 27.3 million primary school teachers need to be trained and recruited worldwide by 2030. This is an enormous number. So how do we go about that? This is a figure from the UIS. One way is to first select the topics we teach. I come from a country where every year we train, on average, twice, probably it's changing, hopefully, twice more physical educator than the number of jobs that are available. So that's a problem, right? When you let people become physical educator, you need to give them the choice of what they want to do. That's very important. You need also to inform people that this is the state of the job market. This is how the job market is. Know that if you become a certain job today, if you study that, you may not have an option later because the job market is changing every day. So that's very important, selected topics, not to force people to take a certain job, but to inform the population. And that's a governmental thing. The second one is online content is everywhere now, especially in computer science and artificial intelligence. So anyone in the world can access this content. It's often hard to study on their own, but one model that we've been trying at Stanford recently with the deep learning class is the flipped classroom format. It turns out that training an instructor is much longer than training a facilitator, a course assistant. And I believe in School of Minds, you have many course assistants that are super talented. So this flipped classroom format allows instructors to teach online and have it scale, and facilitators to work around the world in order to facilitate the understanding of the content for the student. Do you guys have flipped classroom in School of Minds? Not yet? Soon, hopefully. And the fourth one is leverage out-of-the-box AI. What does that mean? For those of you who have worked with artificial intelligence, you might know that many deep learning frameworks allow usage of machine learning without actually understanding the details of the research, science, and math behind. So that's a great thing. That means just like it's easier to code in Python than to code in C, oftentimes, it's easier to use deep learning frameworks rather than coding artificial intelligence directly in Python. And that allows many people, especially talented software engineers, to build AI systems in the industries very quickly. Okay, I think that was the end of the boring part. Okay, so that's the sum up. One other interesting thing is that if you look at the landscape of artificial intelligence, you have many different types of algorithms. One of them is support vector machines. One of them is k-nearest neighbors. If you look at the number of papers published on Scopus by categories, you would see that the main drivers of this AI research are computer vision, machine learning and probabilistic reasoning, and neural networks. So neural networks is one of the networks that we're going to focus on now. It's been one of the main drivers to drive research in computer vision, natural language processing, and speech recognition. Who is familiar with neural networks? Okay. Okay. So we're going to jump into the fun parts and discuss more neural networks. I'll start by a 5-minute technical recap in machine learning, and then we'll jump on fun case studies. Okay? Do you have any question, something you didn't understand from what I said? No? It's okay? Let's go. Up. Okay. So machine learning from a very high level perspective is the following. We have an input. Here it's a cat image. It's a very cute cat. And we have a model in the middle. What we want is if I give this cat picture to my model, I want my model to tell me, yes, there is a cat on this picture. And the way the model is going to tell me that is going to say 100% probability that there is a cat on this picture. Okay? So this model is not good. It's not seeing the cat. It's outputting 0. So ML AI is the science of how do we make this model say 1 when there is a cat and 0 when there is no cat. So let's see how we do that. The first thing we need to do is to define a model. A model is two things in neural networks often. One is architecture, and second one is parameters. You're probably familiar with linear regression, which is a model that fits a line on a data set. So the linear regression is y equals ax plus b. So there is an architecture, which is the line. And then there are the parameters, a and b, which will define the line. So here is kind of the same thing. We have an architecture that defines a function, very complex function that depends on millions of parameters. And these parameters are the one we will learn, the one that will make this function become detect cat. Okay? So now that we know what a model is, we're going to send the cat and see that the output is 0. Who is familiar with what a loss function is? Okay, half. So a loss function is an objective function. What I'm going to say is, what is the truth here? The truth is 1. There is a cat on the picture. What is the prediction? The prediction is 0. There is no cat on the picture. My objective is to minimize this distance between the truth and the prediction. So I'm going to define a function that is simple. It's just the distance between the prediction and what is the truth. That's my loss function. If I manage to minimize this function for all the cat and non-cat images, I will find the right model. Because I want to minimize the distance between the predictions and the ground truth. Okay? So now that I have defined my objective function, I will try to minimize it using gradient descent, an optimization algorithm. Who's familiar with gradient descent? Okay, more people. So gradient descent is going to be an algorithm that is going to minimize this objective function by changing the parameters of the model. So first time I send the cat, I get 0. I look at my objective function, it's very high, my objective function. So I'm going to change my parameters, change them, so that next time I send the cat, I will get 0.2, maybe, better. Come back, change the parameters. Next time I get 0.4, and so on, and so on, and so on, until my parameters are correct. Okay? So we do that many times. That's my favorite, a year of learning how to use Keynote in order to get there. What's interesting in machine learning and deep learning is that many things can change. The input doesn't have to be a cat image. It can be a speech. You work with, you've seen some of the smart assistants on your phones. It can be a text, like translation systems. They take a text and they output a text in another language. It can be also a table on Excel, you know, just numbers. And same, the output. The output can be 0 and 1. Is there a cat or no cat? The breed of the cat, so it can be 0, 1, 2, 3, 4, blah, blah, blah. each number corresponding to one breed of a cat. It can also be a number that is between minus infinity and plus infinity, and that is not an integer, a real number. It can be the age of the cat. Try to predict the age of the cat. That's more complicated, probably. Other things that can change is the architecture. We could have used a line as an architecture, but it would have probably not worked. It's hard to believe that a line would detect this cat, right? So probably we need a complex function. The objective function, here we just defined it as the distance between our prediction and our ground truth. It could have been something else, as long as minimizing this loss function makes the model correct. That's the only thing we want. In this talk, we will see several loss functions. And finally, there is much more things. Instead of using gradient descent optimizer, we could have used other optimizers, for example, and so on. So does this background check on machine learning make sense to everyone? Okay. So let's look at that. I'm going to explain what a logistic regression, which is one type of model that is, let's say, the easiest possible neural network. What is that? We have our cat here. And what we're going to do is think, what is a cat for a computer? Do you know what this image is for a computer? Someone has an idea? What? It's a matrix. It's a matrix of numbers. So each pixel is defined by 3 numbers because it's a color pixel. If it was not a color pixel, it would be 1 number. So this cat picture is a bunch of numbers in matrix. There are 3 matrices, R, G, B, to detect the red color, the green color, and the blue color. Now I'm taking all this matrix and I'm putting it in a vector. So this cat is that. It doesn't look like a cat, but it's a cat. Here. And now what I'm doing is that I'm sending all these values in a computational unit that is called a neuron. This neuron has 2 parts. One part is linear, wx plus b, just like a line. And the second part is a function that will take the value of the linear part and put it between 0 and 1. It's a sigmoid function. Why do I want this function? Is because I need my number output to be between 0 and 1. I want a probability, so I need to put this activation function here. Okay? That was a question I wanted to ask. So here, the network says 0.73. It means that with 73% probability, the network thinks that there is a cat in the image. So it's pretty good. The network is correct. My question is, if we had to change this network to detect not only cats, but also dogs and giraffes, how do we change the network? Yes. Can you speak louder? Multiple nodes, multiple outputs. Yeah. So we can use 3 times the same thing we did. And the first one would be responsible for dog, the second one for cat, and the third one for giraffe. Make sense? Now, what kind of data do I need in order to train that network? Images of dogs, images of giraffes, images of cats? Right. What's the ground truth? How do I label my data set? Up to now, with the cat, I labeled my data set by taking an image on a cat and saying 0 if there's no cat, 1 if there's a cat. So the label is just 0 or 1. In this case, what is the label of an image? Yeah, 010. That's true. Instead of having just 1 number, we have a vector with 3 numbers. Each number is 0 or 1. So for this cat image, the label will be 0, 1, 0. If I had a dog image, the label would be 1, 0, 0. And if I had an image with a dog and a giraffe, which is very unlikely, I would have 1, 0, 1. Using this data set, I can train such a model. So you see that oftentimes the strategic decision on how to collecting a data set is what is important in a problem. That's the main deal. It's, do we have a data set with such a label and such an image? That's the main deal. Okay. So now, what I'm going to say is that what we can do in order to build neural networks, because that's what we're going for, is we can also connect these nodes, neurons, to another neuron that comes after it, and so on. We could make as many as we want. We can just stack them on top of each other. And each of them is a computational unit. The more you have, the more complex is the function you're creating. The more you have, the more parameters you have to train and learn. Okay? So this is a neural network. So this one is a little more complex than the one we had before with only one element. And it's still very good. It's a cat. So if this number is more than 0.5, it's a cat. That's the threshold you decide. So was that easy for you, or was it easy for everyone? Yeah. Cool. So one thing that we have to know that is very important for this lecture is, let's say I give the face of a human to this network. And this network has been trained to understand human faces. So it's not a network that detects cats. It's a network that detects human faces. I give a human face from the left here. What happens in the first layer, if I extract the information that these guys are looking at, I will find this. The first neurons are exposed to pixels. So it's hard for them to understand what a face is. It's easier for them to understand the edges, because they can combine pixels together. Like this one will receive information from all the pixels, and it will combine them to figure out some of the edges. What happens if I look in this layer? This layer receives as input not edges, but more complex information, because these guys have built edges. So this one receives edges, and it's able to probably construct more complex attributes of the human face, like eyes, or nose, or ears, and then give it to the next one. And the next one receives more complex attributes and is able to construct faces. Do you understand this complexity that grows with the network depth? So that's it. That's one thing we want to know, is that a trained network, if the network is working well, that's what it's going to learn. And this technique is called encoding information. So if I give an image and I select one part of the network, I will get some information from this network. The deeper I go, the more complex the information. The lower level, the more edgy the information. Okay, fun part. So now we're going to go over several case studies, and our goal will be, can we think and define a loss function that is right for our problem? A good objective function for our problem. That's one of our goals. Can we choose the right architecture to use? And finally, can we choose the right deep learning approach? So it's all about, it's not about math, it's more about experience and decision making on structuring a machine learning project. Let's go. Okay. We will start by a simple example of day and night classification, and then we will go face verification and face recognition, which is fun. Then art generation, which is a little more fun, and then my favorite is trigger word detection. Trigger word detection is like, hey Alexa, or okay Google, ni hao Baidu, or all these all these words that need to be spotted. You want to build a network that detects only the word activate, let's say. That's what we will try to build. So let's start with given an image, classify as day or night. Does the problem make sense? Image, is it day 0 or night 1? So, can someone tell me what is the data set we need to solve this problem? Images of what? Images of day and night. So if we have only day images, it's probably not going to be very good. If we have only night, it's not going to be very good. We want probably both. Okay, so let's say that. Second question, how many images do we need? I wrote 10,000 here, but you can argue that. Like, how many images do we need to solve this problem? One image? Not enough. 1 million image? Probably don't need that much. So how do we know how many we need? It's about the experience of the model. So you want the model to experience a lot of things. That's what you mean. Yeah, I think it's a good way. What's the experience needed to figure that out? Oftentimes, this is going to be very hard if it's your first project. If it's not your first classification project, what you can do is, oh, I remember I built a cat classifier, detecting a cat. Do you think detecting a cat is easier or harder than day and night? Easier? Who say easier? Okay, who says harder? I think it's harder, yeah. Because the cat can hide. The cats are very, very sneaky, right? So yeah, this one is easier probably. So I remember that my cat classifier worked very well with 50,000 images. We probably need less here. Another pointer. This project can be very difficult. Can you think of examples where day and night classification is very difficult? Yeah? Sorry? At sunset. Yeah. So images at sunset or sunrise or sundown, it's very hard to know if they're day or night. That's true. Yeah. Fireworks. Yeah, fireworks is usually at night, but there's a lot of light. So maybe the model could be confused by that. Now let me ask you a question. If I take a picture here, would a human be able to say if it's day or night? Yes or no? A human would be able to say, I can see it's night, if you look behind. For a model, it's very complicated. Because a model will probably learn to look in the sky. If you look in the sky, it's day, it's not night. But if you look at the windows, you will see it's night. So if you have pictures that are taken inside, it's very complicated, this problem. It's getting more complicated. So this number depends on the complexity of the task you're trying to achieve. If you have a more complex task, you will need more examples. And oftentimes, the way you will figure that out is you will start with 1,000 images. You will train your model. You will see it's doing well, but there are like 20 images that it's totally getting wrong. Then you look, and then you see that all these images were indoor. So the model doesn't understand indoor. So you go out and you take pictures indoor. So you go in, you take pictures indoor with some windows. You add them to your data set until the model understands it. Okay? Yeah. Another question is split or bias. When you have a data set of 1,000 images, you need to take some images to train your model, to teach it, and you need to take some images to validate that the model is working. Because if you give the images that the model has already seen to test your model, it's not going to work. It's going to show that the model is great, even if the model is not that great. So you need to split it. And oftentimes with this size of data set, we will split it in 80% training to help the model learn, and 20% testing to understand if the model is working. Okay? What's the input of our model? The image. So this type of image. So this is the Louvre Museum in Paris. Now, what should be the resolution of the image? Who has a guess? Depends on how complex it is. So what do you mean exactly? If I tell you, you have 3 hours to give me this number, the resolution I should use, how do you do that? Knowing that high resolution has more information, but it's much longer to train a network if the images are big. It's much easier to train a network with small images. So we want a trade-off. We don't want the image to be too small because maybe the network will not see that it's the day or night, and we don't want the images to be too big because it's too long to train our network. Yeah? So the way you can do it, anybody has an idea, by the way? It depends on the data you have available, but you can resize the data. You can have very high resolution and resize it when you train your model. So we look at what other problems we solved before, and we decide based on that. Yeah? Any other ideas? So you say we can test. We can try with low resolution, see how it goes. Then we can higher the resolution, see if it's better, and so on, until we find the best resolution. That's a good idea. There is something faster. I told you you have only 3 hours. So one way is, I can take a picture, like 10 pictures, day and night, and I will print them in 3 different resolutions, 10 by 10, 50 by 50, and 100 by 100. Sorry? What did you mean? In the middle range, you mean? Low. Low is better. So the way we're going to figure it out is I'm going to show these images to humans. And I'm going to ask them, can you tell me on this 10 by 10 image if it's day or night? If a human can perfectly classify all the images, the 10 images, I will probably consider that 10 is right. It's enough. It's enough for a human, it will probably be enough for the model. If it cannot, I will go up, and so on, until I find the right resolution. And this experiment can be very quick. I just need a printer or a computer and a few people. Right. And it will save me a lot of time. Because if I didn't do this 1 hour experiment, I will try a bunch of different resolutions. It will take me several days to figure out what I should have done. Okay, so resolution. Actually, for this one, 64 by 64 is a good one. It's enough. You can see the windows, you can see the details, and so on. What's the output of our model? 1 or 0. So it's a probability between 0 and 1. 0 for day, 1 for night. What is the last activation? So the function that is the last function of our network. Sigmoid is a function we've seen together earlier. The one that takes a number, puts it between 0 and 1. What's the architecture? Probably a shallow network would do the job. I don't need to have a very complex function, very deep network. I can take a shallow network. It will probably do the job because it's not too hard. And that's, again, based on your experience of building other projects. The loss function. So who is familiar with the binary logistic loss or binary cross-entropy loss? Okay, a few people. So this is an objective function that is comparing the truth to the prediction. It's a distance, like it's very similar to the one we discussed together. If this function is small, it means the network is good. If the value of this function, the value of L is large, it means the network is bad. No need to go into the details here. Okay, any question on day and night before we detect faces and verify them? No? Okay, so let's jump to face verification. A school, let's say School of Mines, wants to use face verification for validating student IDs in facilities. So I assume that maybe when you enter the canteen to eat, you have an ID and you swipe the ID. Is that correct? So assume you have an ID and you swipe it to enter the canteen. What they want to build is something more advanced, where you have an ID and you swipe it. Oh, sorry. So the way it works in Stanford, for example, is when you swipe, your face appears on a screen, and there's someone sitting behind the screen checking if it's you. If it's not you, they're not going to let you in. So what we could do is build a verifier that doesn't need someone to sit in front of the screen, but when you swipe your card, there is a camera that looks at you and says, is it the same person or not? That's the problem here. Does it make sense? Okay, so what's the data we need? Pictures of whom? Of our students. So pictures, so probably when you start enrolling in a university, you give one picture. Maybe that's enough. Let's say we have one picture from every student. Do we need other pictures? Probably we need pictures of not students, right? So we can find that online. There are public data sets available with faces. Okay, but let's assume we have a picture of every student labeled with their name. So this is Bertrand, and this is his picture for his university. Okay? What's the input of our model? Is it this picture? No. Which picture is the input of the model? The camera picture. The camera picture. So this is a picture of Bertrand trying to enter the canteen. And the output of the model is, oh yeah, one question is resolution. What do? We do the same. I will print several resolutions and I will ask Bertrand's friends or even random people, probably his friends, do you recognize who is it? If they don't recognize, it means the resolution is too low, right? If they recognize, it means we're good. So we will try to find it. And in fact, a very classic resolution here is 412 by 412, which is much more than day and night. It makes sense. You need to see the nose, you need to see the ears, the eyes. Sometimes it's not too easy. And what's the output of our model? Hmm? 0 or 1? Or the name? Student or not, yeah. So it's you or it's not you. So is it the same person that corresponds to the card with the image in the database or not? The question. What architecture? Let's say you had to build the easiest version of this project. How would you do that? No need to do AI, like the easiest version of this project. Cross-correlation between the two images, possibly, yeah. Or even simpler, just you take the two images, you do a pixel difference. So you just compute the pixel difference. This is not good. And the reason is, if you do the pixel difference, this pixel is white. This pixel is probably dark. And these pixels don't really matter for us. But if you do the pixel difference, you get 255, which is a very high mistake. Other problems with pixel difference is that probably the background lighting can be different. Probably the person can wear makeup or grow a beard. So Bertrand here, he has a beard here. But here, he was very young. He doesn't have a beard. The ID photo can be outdated. This is much before that one. So pixel difference will not work, probably. So we have to find something more interesting. The way we're going to do it is we will use what we've seen with encoding information. We will train a network such that if I give this image to the network, I will get a vector. And this vector hopefully encodes information about the nose, the eyes, and so on. That's what I want. Then I can run the other image in the network. And I can get another vector. And I can compare these two vectors. What's the distance between these two vectors? Is it more or less than the threshold that I define? If it's less, it means it's probably the same person. If it's more, it means it's probably a different person. Does this make sense? So you're saying the model extracts information about two different persons, and you think that this information will contain much more than needed? Is that it? Oh, okay. Yeah. So you're describing. I'm going to repeat so that everybody hears. Another approach to that is you take the two images and you give them to a network that is going to decide is it same or different. That's also possible. That's actually what we will do. So one question I have here is, how do we know that this network encodes in this vector the right information? If I start with a random network, this vector is going to be garbage. It's going to not mean anything. Same for this one. So I need a way to tell my network, you should encode meaningful information of the face. So how are we going to do that? It's very close to what you talked about. We're going to use a very interesting technique. So first, let's assume we have a lot of data of faces. We have many faces. What we're going to do is we're going to generate triplets. What I want, oftentimes when you want to choose your objective function, you ask yourself, what do I really want my model to do? What I want my model to do is, if the model receives two images of the same person, I want the two vectors to be very similar. If the model receives two images of different persons, I want the vectors to be very different. Right? That's just summarizing what we want. Now, we will generate triplets. With one image is called the anchor, one image is called the positive, which is the same as the anchor, and one image called the negative, which is a different image from the anchor and the positive. Now, what we want is to minimize the encoding distance between anchor and positive and maximize the encoding distance between anchor and negative. Right? So let's look at several losses. Here are three proposals, A, B, and C. Can you take 30 seconds and try to figure out which of these three is the one we want to use? A, encoding of A is the vector of anchor. Encoding of P is the vector of positive, and encoding of N is the vector of negative. Which one of these is going to be the right objective function? Okay. Someone wants to give it a try? So let's do. Who thinks it's A? Okay, 5, 6, 7. Who thinks it's B? Okay, about 9, 10, 11. Who thinks it's C? Okay, 1. So someone who said A. Can you explain why A? Who wants to try? You want to try?
Because really you need to minimize the distance between the A and P, and you need to maximize, that is the same, that minimize the negative way of, or the negative operation of the distance between A and N.
Yeah, so that's correct. That's correct. Look at this. This one is a squared distance between these two vectors. So if we want to minimize this function, we want to minimize this, right? So we want the encoding of anchor and positive to be the same. If we want to minimize this L, we want to maximize that because of the minus here. If this is big, this is small. So we want this to be maximum, so we want encoding of anchor and negative to be different. So A was the right answer. Does it make sense to everyone? Okay. So this was what we had at the beginning, but it's changing a little bit for this project. Instead of an image of a cat, what we're sending to the model is 3 images. Instead of getting an output to be 0, what we're getting is 3 vectors, encoding of A, encoding of P, and encoding of N. Instead of defining a simple distance, we're defining a complex distance that is the following, that we just saw in the previous slide. All the rest is the same. We will change our parameters in order to minimize this L. Change them. Every time you give again new images and you change them and so on. Until my favorite visualization, and you get the right parameters. One more time. Any question? Does that make sense? So now, because of this, I know that when I give an image to my model, it's going to encode the good information. Because it had to, in order to minimize this loss. It had to understand the face. Otherwise, this loss will not be minimized. Any questions? Okay. Now, let's say we change the problem a little bit. Up to now, it was face verification. So, student enters, student swipes, images is identified in the database and compared to the camera image. Is it the same person, yes or no? It's verification. A more complex version of it is there's no ID, no swipe. You enter, camera, is it the person or not? Who is it? This is harder, right? So how do you build that one? Yeah, very good idea here. Maybe we can just reuse what we did, take all the images in the database, run them in the model, save the vectors. When I enter, boom, picture, take my vector, compare it to the vectors in the database, find who it is. This is called k-nearest neighbors. Who is familiar with this model? It's just take one thing, look in the database, what are the closest thing? That's what we want to do. So it's not a big step from what we've been doing so far. Another one, you see it sometimes on, like, I remember like 3 or 4 years ago, I was on my phone and I look and my phone asks me, is this your mom? And I say, yes, it's my mom. And then, boom, I see a folder with all the pictures of my mom. And then it asks me, is that your dad? And then, boom, I see all the pictures of my dad in one folder. So this is very similar. It's using the same idea. It's another network called K-means. So what it's basically doing is that it's looking at all the vectors you have in your phone from all the images, and it's finding the closest clusters. So you know there's one cluster that is here. It's probably all the images of someone. So if you just take one of them and ask the person, who is it? You know that all of them is the person, is the mother, for example. Does it make sense? So not much harder. The verification was the most complex to understand. The rest is easier. Do we have more time, by the way, or no? Another one that is fun is art generation with artificial intelligence. So how do you generate art with artificial intelligence? So I'm going to speed up here a little. The data you need is, let's say, anything. Let's say you have any data, any images in the world. So this is what I call a content image, what we call a content image. Do you recognize what it is? It's Medellin, it's the metro. Now, this image is called a style image. Do you recognize what it is? It's here, right? It's a painting from Pedronel Gomez, which is here. What I would like to do is I would like to take the content of the content image and try to paint it with the style of Pedronel Gomez and get something like this. Okay? So this is the metro here. You see the metro in the middle? So that's what we will summarize as art generation for the purpose of this discussion. Okay? So how do we do that? That's a fun problem, but it's a little complicated. So how can we, in 10 minutes, construct this image? Okay, let's try to do it. What architecture do we need? Any ideas? So a convolutional neural network, in fact, that's true. So for those of you who don't know what a CNN is, a convolutional neural network, consider it's a network that uses neurons, neural network, but it's specific to image data, let's say. Not always, but let's summarize it like that. So what do we want this network to be able to do? What do we give to the network? You give it 2 images and you want to output a mix? Probably. That's going to be very hard. So let's say we simplify a little bit. We say that we have a pre-trained model. What is a pre-trained model? It's a model that has been trained on another task. Who knows what ImageNet is? ImageNet is a database with millions of images. Each of them have a class. And there's 1,000 classes. So a network that has been trained on this database can recognize virtually anything. It can recognize a cat, it can recognize a dog, it can recognize a car, it can recognize anything. So we know that if I give an image to this model, like this image, for example, if I give it to a model, it's going to give me a class. It's going to tell me probably buildings, maybe, or metro. I don't really care about the class. That's not what I want. What I want is my beautiful image. But what I remember from the part before is we know that this network, if we look in the middle, we can extract some information about what's inside, right? Specifically, if we look here, I look here and I extract the information from this place. I will get a vector. What do you think this vector contains? A compressed representation of the image. What more precisely, what does this compressed representation has? Is it like buildings, all that, or is it edges? Is it complex information in each neuron, or is it edges? Probably edges, because we're closer to the beginning. So this, what I get probably from that is I will not get too much complex information. I will get all the edges. Oftentimes, we define the content as edges, right? If I just take all the edges of the image, I will get my content. So let's say I take this vector. Now, I'm going to run the painting in the deep neural network. And I'm going to look a little deeper here. Why do I look deeper? Because I don't want to keep the edges of this image. What I want is the style, the color, the complex information about the image. So I want that. So I take it and I call this style S. There is actually another operation happening in the middle, but I'm not going to describe what it is. It's called gram matrix. So now we have 2 vectors. One is content C, and one is style S. Let's keep this vector in mind. So I put them in the lower part of the slide. They're going to stay here for now. So content C is the vector encoding the content of the content image, the metro. Style S is the style of the style image, encoding the style of the painting from Pedro Nel Gomez. Okay? So what's the image generation process? How can I generate a new image based on these 2 vectors? Let's see. I can start from a random image. I can run this random image in the network. And I can look in the same places. I can look in here and get the content of my random image. I can look deeper and get the style of my random image. Now, I can compute a loss function. We will see what it is. And I will update the pixels with the gradient. So instead of updating the parameters of my network, I will change the pixels in order to minimize my loss function. That's the main difference. My network is already trained. It's very good. What I need to change is the picture, because I want to generate a nice image. So I'm going to change X, this image, in order to minimize the objective function that I defined. So now we have four vectors. Content G, the content of the generated image. Style G, the style of the generated image. And content C and style S. So the question is, if I want to get my painting after iterating and minimizing this loss function, which of these three losses is the correct one? Someone wants to try? So who says A? No one. Who says B? Okay. Who says C? Okay. So those who said B, someone can explain? Yeah.
We want to maintain the style but also maintain the content. So the objective is to give the same priority to both losses.
Yes, that's correct. And the difference with the previous one is that we have a plus here. We have a plus. So we want the style of the two images, the style of the style image and the generated image to be similar. So that will ensure that the painting, the generated image of the metro will look with this painting. And the second term ensures that what I will see is a metro in the city of Medellin. Okay, that's correct. And so that's what we have. And the loss function is the one that you explained, the B. Here it is. So you can go and generate nice images like that. Okay, so we have about 6 more minutes. So I'm going to just describe quickly what this one is. So let's say given a 10-second audio clip, so we have 10 seconds of audio, we want to detect the word activate. It's a speech recognition task. Instead of detecting Alexa, we will detect activate, let's say. So what data do we need? Let's go quickly. Speech data. So bunch of 10-second clips. The 10-second clips could contain many different words, not only activate, like lion, kitchen, school, and so on. The distribution of this speech should be very wide. I should be able to have all types of accents if I want my network to work with all types of accents. I actually built with Professor Eng and Younes Bensouda-Mouri a version of this network. And the first time we trained it, we thought it was working very well. And then after some time, I saw that my German friends, they were not detected. So none of my German friends were detected by the algorithm. So the algorithm actually didn't have any German accents in the database. So I went back, gave a few calls to some German friends, asked them to give me some words, and put it back in the database, and so on. So that's the type of thing you learn. What's the input? It's a 10-second audio clip, and in the 10-second audio clip, you can have negative words that are not activate, like the purple ones, and positive word, activate, in the middle. What's the resolution? You can ask an expert. I would directly go ask an expert in speech recognition, what's the sample rate I should use? What's the microphone I should use? And so on. What's the output of my network? 0 or 1? Who said 0 or 1? 0 or 1. So let's do a small experiment. So here we have 3 audio clips. on the top. And there is a word that is the trigger word that I'm not telling you, okay? So you're acting as a model. You're acting as a machine learning model right now. The machine learning model doesn't have any context. It just sees the raw audio and 3 numbers. It sees 1, 0, and 1. It means the first clip contains the word, the second one doesn't, and the third one does. So can you find the trigger word? Okay. We probably don't have sound, but let's try. Okay, we don't have sound. So I'm going to make the voice. I don't remember. So the interesting thing about this, this experiment is that if you listen to it, it's another language that many of us don't speak. And every time I try this experiment, apart from one time, people cannot find the word because it's too hard. It's a language that you don't know, and you have 10 seconds, and you know that somewhere there is a word you want to detect, but you don't know which one. So it's very hard. The interesting part is if, oh, you have it?
No, it doesn't sound. You have a cable.
Okay. Okay, the second labeling scheme, the one below, is the right one. With this one, you can easily find where the word is. So that was one of the main learning from this project, is choosing the right labeling gives you actually the right solution for your network. Okay, and on this, I'm going to give the microphone to Alejandro. So it's a pleasure for me and also for Alejandro, who's leading the team in Colombia, to be here and talking to many smart students and professors. So thanks a lot for having us. I'm going to stick around in case there is any questions after the talk. A few things we wanted to say. So deeplearning.ai is something we've been working on for some time, and we teach AI classes online. Professor Eng, Younes Bensoudamouri, and I have built 5 artificial intelligence courses that are available online. AI Fund and Arista is the fund that Andrew Eng has raised in order to build verticals and change several industries with artificial intelligence. We have 2 offices, one in Palo Alto and one in Medellin, led by Alejandro. And if you have any questions or are looking for opportunities to learn AI and build systems, both for software engineers and machine learning engineers, both of these, there are plenty of talented. So I see some of them are here. So there is a very good team in Colombia, and the 2 offices work hand in hand together. So you can apply through these very easy links. And I'm going to say thank you and let the microphone to Alejandro. Thank you, everyone.
Yeah. Okay, yeah, thank you, Kian. It was a nice presentation. Professor John Branch told me to basically lead the question session. So I will invite Kian to be in the stage with me. If you want to speak in Spanish, you can ask in Spanish. That's also okay. And I invite really people to apply in these links. It's like we have really nice challenge for machine learning engineers and as good challenges also for software engineers. Because one thing is train the models, the other is put it in production and really transform a real industry. So I really invite everybody that want to give a shot and try to work with a nice team, like half of them are in line there. So you feel free to, if you bring your CV or you can apply through the link, it will be nice. Okay, so John, how we coordinate the question session? If someone has a question, just raise the hand and Professor John will bring the microphone there. So, yep.
Hi, thank you so much for this amazing presentation. If you have in front of you the CEO or a director from a hospital that is interested in doing all of this, what will be your advice? How do we start?
So the question is, an advice to a CEO of a hospital on how to incorporate some of these projects. So I think there's a lot of things you can do. It's very important to strategize what you want to do. So for example, when Landing.ai and Alejandro would work with a company in order to transform their projects with artificial intelligence, the first thing we will look at is it a high-stake project for you, for the hospital? I assume that the hospital has palliative care, inpatients, outpatients, cardiologists, dermatologists, everything. So is there one of these projects that is very valuable and is seen as an important project to solve in the community, in the hospital? If you identified one of these, is it easy to solve it? I think, and Andrew Ng talks about it a lot, it's good to start from an easy project so that it gathers proud of all the hospitals to try out these type of technologies for their own projects. So I would say one way is to work with companies who know artificial intelligence, like Landing.ai. One way is also to train your employees, to push them to take classes by sponsoring education for them, and so on. So these two ways are usually very good ones. And I know how hard it is for an institution that is expert in A, but would like to change some of its expertise with B. It's hard to see where to look for. Yeah.
And what mistakes would you ask us not to do?
I think one mistake would be to try to recruit your own engineering team and solve the projects. Because of many reasons. It's hard for a hospital to recruit an engineering team. Oftentimes you will have to train them a lot, and at the end it will take you a year to gather the team and a year to train them and 2 years to solve the problem, and the field is moving very quickly. So that would be one mistake that I think hospitals should not do.
Thank you.
And Alejandro, if you want to add things, just feel free.
Thank you for the talk. I have a question for both of you. When Alejandro was presenting the challenges for LA and artificial intelligence, you specifically said that one of the focus or the challenge was to promote talented teams. You didn't say people, you didn't say individuals. You specifically say teams. Why so?
Well, I really think once you have like a couple of good engineers together, they work better than 5 individual engineers. So if you manage to train your teams to work between them and cooperate within them, they will have better performance. In fact, we are changing actually the way we work in artificial intelligence. I can tell you some of the changes we have is in software engineering, traditionally you have 1 week, even 2 week sprints, while we are trying to push our teams to have daily sprints. So we develop all the day, we leave the algorithm running during the night, and in the morning, the first thing we try to do is check what happened with the algorithm and try to improve what works and fix what it doesn't work.
Okay, thank you. And in industry, we have a challenge. We have the challenge of managing managers' expectations and keeping enthusiasm high about artificial intelligence deployment. What are your thoughts on that?
Well, actually, Andrew just released a couple of weeks ago a new document about teaching your managing, the managing of the companies, what is AI and what can it be done with AI explicitly. So it's trying to keep the expectations in the right level, not over-hyped, but also that they know that we can create value with that. So that's the challenge of this technology. Someone else?
Okay.
There is a microphone here.
Silva, hola. Okay, my question is, do you think the economy of Latin America is prepared to receive professionals in those areas? Well, are there jobs available in Latin America?
Well, absolutely. I think We are looking for talented people, but I can say Bancolombia is looking for talented people. There are plenty of startups looking for talented people in AI, and the type of things you can do with some small investment is amazing. So yeah, I definitely think the economy is ready for that.
So I think there's a, and I'll jump to the question after. Like as a student or professional, you always have the question of what do I want to learn? Because people in computer science, they're lifelong learning. It's like every day you learn. If you don't learn, you don't keep the pace with the industry as a computer scientist. And many engineering fields are like that. So I would say one thing that is important to consider is which team I will join, what I will learn with this team. So what we do is we have the ability to train engineers in artificial intelligence because that's the knowledge we bring. So someone who's strong at coding, joining us, will learn a lot of artificial intelligence and deploy models. If you want to delve into healthcare, hospital, you want to be a software engineer, very strategic to join a laboratory that does healthcare because you're going to be surrounded by experts. You're going to learn with them. So this is more career decisions on what do I want to know in 2 years, which team I will join, and so on. Yeah, but I think they're great companies. I know several companies are represented here from Colombia. So I think as a software engineer or a mathematician, today there's a lot of opportunities. And also for all engineering fields, because a physics engineer needs to know math and computer science. Oftentimes, it makes it easy to join the AI field when you know these two basis foundations.
Thank you for the talk. This question is about landing AI and how open is landing AI to co-create and collaborate with local industries. I understand that the first focus is on manufacturing, but how can the ecosystem in Medellin can like provide these problems and challenges for take advantage of the knowledge of using AI to solve these problems outside of manufacturing, and also if you have a roadmap to tackle these specific sectors, first manufacturing, then what, and how can we join forces to bring AI to truly be like the new electricity?
Yeah, well, in landing, basically, we are targeting different problems already. And something we try is to find a client or a partner, basically, on which we can prototype technology that can be generalized in any country, for example. So let's say if we have a client in Asia, we can use that technology in Latin American clients, right? But we need to find those clients that are willing to try something new and that are not afraid of risk. So once we find those clients, we start working with them. Of course, it's also a matter of scale, right? We have a team. We are growing fast, but collecting a talented team is not that easy. So once we manage to create these nice teams, bring the people of Deep Learning AI, the people of Coursera, to help us to basically start creating more machine learning engineers in the city, I'm sure that will spread all around the city, and not only from landing AI. I can assure you it will start appearing companies with the people that is not working with us, and we are perfectly fine with that. That we cannot teach people just to join us. That's basically, they teach in Stanford 1,000 people, and in Deep Learning AI is around 100,000 people registered in their courses. So we only have 150 people in the company. So that people is already in the market, ready to make great stuff.
Thank you for the great talk. So I have one question. As an entrepreneur thinking of developing a product that is related to the Sustainable Development Goals, so SDGs, you know, food production, agriculture, water management, would you say that Latin America or Colombia is not the right place to establish such a startup because it's not ready maybe for helping the development of such startups?
So I think the reason we're here and landing.ai is in Colombia is because we think that there is a pool of talents in Colombia. That's the main reason, right? So my answer to that would be, I think there is the opportunity in Colombia to hire good talents and build meaningful products using AI. One thing that is that can be a challenge is Silicon Valley is ultra connected with AI. It means every day you hear new paper coming out, you can keep up with the research very easily. So if you decide to start something in Colombia, which I hope you will, beware that you have to listen to some hubs in the world where a lot of technical advances are happening. I think there's not only Silicon Valley, there's much more. But attracting the talents here, there are a bunch of very good coders. So I think there is an opportunity. I'm not an expert in what's the market opportunities in Colombia in terms of agriculture, manufacturing. Financial services are strong. You know probably more than I do. But in terms of talent pool, I think there is enough to build a meaningful company here.
I think something really important that I'm also from Medellin, so I really think something important that we have to do is start thinking that we can do everything only with Medellin, right? We need to start thinking globally, and if we need to bring people from other countries in Latin America, we need to do it, right? And if we need to bring investment from Palo Alto, we need to do it, right? It's not an option. We are invited to dance, but we need to really open ourselves to be in the party, right?
Bueno, ¿alguien más? No. Perfecto. Muchísimas gracias a todos ustedes. Los esperamos en próximos eventos y bueno, que tengan una feliz noche. Mucho gusto, Diana, Alejandro. Usted sí, son total. El doctor